बिस्मिल्लाहिर्रहमानिर्रहीम रब्बिश्रहली सदरी वयस्सिरली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we will continue section 2.5 acceleration from the book Physics for Scientists and Engineers with Modern Physics by Serway and Jewett, 10th edition. For the case of motion in a straight line, the direction of the velocity of an object and the direction of its acceleration are related as follows. When the object's velocity and acceleration are in the same direction, the object is speeding up. On the other hand, when the object's velocity and acceleration are in opposite directions, the object is slowing down. To help with this discussion of signs of velocity and acceleration, we can relate the acceleration of an object to the total force exerted on the object. In chapter 5, we formally established that the force on an object is proportional to the acceleration of the object. Fx is proportional to ax, that means the force in x direction is proportional to the acceleration in the x direction. This proportionality indicates that acceleration is caused by force. Furthermore, force and acceleration are both vectors and the vectors are in the same direction. Therefore, let us think about the sign of the velocity and acceleration by imagining a force applied to an object and causing it to accelerate. Let us assume the velocity and acceleration are in the same direction. This situation corresponds to an object that experiences a force acting in the same direction as its velocity. In this case, the object speeds up. Now suppose the velocity and acceleration are in opposite direction. In this situation, the object moves in some direction and experiences a force acting in the opposite direction. Therefore, the object slows down. It is very useful to equate the direction of acceleration to the direction of the force because it is easier from our everyday experience to think about what effect a force will have on an object than to think only in terms of the direction of the acceleration. From now on, we shall use the term acceleration to mean instantaneous acceleration. When we mean average acceleration, we shall always use the adjective average. Because Vx is equal to dx over dt, the acceleration can be written as ax is equal to dvx over dt. We know Vx is equal to dx over dt, therefore ax is equal to d dt of dx over dt, which is equal to d square x over dt square. That is, in one-dimensional motion, the acceleration of the particle equals the second derivative of the particle's position x with respect to time. Pitfall Prevention 2.4 Negative Acceleration. Keep in mind that the negative acceleration does not necessarily mean that an object is slowing down. If the acceleration is negative and the velocity is negative, the object is speeding up. Pitfall Prevention 2.5 Deceleration. The word deceleration has a common popular connotation of slowing down. We will not use this word in this book because it confuses the definition we have given for negative acceleration. To summarize, force is proportional to acceleration, force is a vector, acceleration is a vector, and they both act in the same direction. If the object is moving with a certain velocity and we apply a force in the same direction as the velocity, the object speeds up. That is because the velocity vector and the acceleration vector are in the same direction. On the other hand, if the object is moving with a certain velocity and we apply a force opposite to it, in that case the object slows down. That is because the acceleration vector and the velocity vector are in the opposite direction. Acceleration is the second derivative of position with respect to time. May Allah bless us all. Thank you for watching. Allah Hafiz.